Ladies and gentlemen, hello. This is Philip from ab9il.net and the YouTube Mach 7 Radio Intercepts channel. This is a short video with a few tips for all of you who would like to make high-quality recordings of interesting radio traffic you find while you're tuning around on WebSDR and OpenWebRX sites, or if you're using your own hardware on your own WebSDR interface or OpenWebRX interface. The reason I'm making this video is because I found a lot of interesting uploads on the net with interesting traffic and really bad sound quality. With just a few considerations and a few techniques, the recordings can be made to sound very good. Good enough for archiving, good enough for sharing with other people, and even sharing with the news media when you find a historic event happening that's documented in radio traffic. The main problem is that there are too many acoustically coupled recordings where a person is listening on an SDR and they find something of interest and they haven't thought ahead of time about making a recording. They haven't set levels, set up the equipment. They've just noticed something and grabbed their smartphone or camera or other recording device, and they'll hold the microphone up near the speaker, and the recording audio does not sound good at all. Another problem is levels are often improperly set. Mostly the levels are too high. So there's audio that's overdriving the recorder, there's clipping, there's distortion, there are other artifacts that are unpleasant to listen to and totally no good for archiving something of interest. Sometimes it's not the audio gain that's set too high, but the RF or IF levels. In an SDR, well, it's the automatic gain level that's set too high, and it causes a lot of problems when listening to a strong station with a moderate level of background noise. We'll talk about that later. Other than level settings, sometimes the recording is of a single sideband station that needs to be precisely tuned, and the listener does not have it precisely tuned in, so we're listening to a voice that's at the wrong pitch. It sounds unnatural. Let's talk about the Sdr interfaces for a bit. We'll go into a little bit of detail, enough detail for you to adjust it and make for a good recording. The WebSDR interface has been around for a while. It's a mature code base and it's still improving. It's not open source, so we don't really get to look deep into the code and make our own changes and hack and modify it and make a better interface. Be that as it may, it's actually pretty good, and again, it's getting better. I go away for a while, listen to other kinds of SDRs. When I come back to the WebSDR sites over in the University of Twente or some of the other ones that are more often updated, I'm very happy to find new features. One of the more important new features is adjustable AGC, the automatic gain control and audio levels. And you can adjust those precisely for what you're listening to, and you can make really good sounding recordings. The server operators have a lot of freedom with WebSDR. They can set the controls to different places on the web page, so they can adjust it to look good, to be usable, and they can add features or they can not implement features if they don't wish to. By and large, the features are pretty good. I wish there were more sites with synchronous AM detection, but AM wide and narrow filters, sideband wide and narrow filters, that's good enough for most voice listening. The front-end hardware on the WebSDR interfaces. It can be just about any kind of hardware. A lot of the stations that receive broadcast band AM in medium wave, long wave, those are RTL SDR devices. And there are other devices that can be used as well. We're seeing more and more SDR play and Airspy devices that are on the other end of the WebSDR interface. So that's good. We want to see the WebSDR interface used for advanced equipment. The other interface that I'll talk about briefly is the OpeWebRX interface. That started as a college project from the original author, who refined it, released it to the public, and it's been developed by the people who create the KiwiSDR. And there's another ham, an amateur radio operator, who is continuing to develop the OpenWebRX code. He's improving it. There's a fresh version out which uses Python 3. And it's very good because it's very customizable. You can set the audio gain, the RF gain, the filters, and it also has built-in digital decoders. It has an IQ mode where you can get quadrature output, and you can feed that into a DRM receiver or some other kind of digital demodulator on your own equipment, and you can do some sophisticated DSP work with that. So you can record from the internet, or you can record from your own hardware using those two interfaces, and the end result is the same. Well, let's talk about specific things that you can do to make better recordings. Number one is do not acoustically couple your receiver into the recorder. Most of us are using either Windows or Linux, and you can install a good recorder, screen capture utility, or an audio-only utility on the same computer that has the SDR interface. In Windows, you can use virtual audio cable to route the audio from one piece of software to another, and it stays in the digital domain. There's no loss of quality with the signal running from a speaker through the air and into a microphone. There's no background noise, no coughing, sneezing, dogs barking, or phones going off. It's nice, clean digital audio from one end to the other. All you need to do is set the level and you're good to go. In Linux, there's the jack audio and also the pulse audio systems. Jack is a bit complicated, but it is used by professional studios. It's sophisticated and you can do just about anything with jack, but it's not easy to use. Pulse audio comes as default on a lot of Linux distributions, including Ubuntu, Linux Mint, and many other distros. It's easy to use. I would suggest using pulse audio and simply using pulse audio volume control and moving the audio from one application to another using that. You don't have the product called virtual audio cable in Linux. That's a Windows product, and I believe it's closed source, but you don't really need it. In Pulse Audio, you can create a virtual cable, and you can use that source and sync to move audio from one application to another. You can tie it onto multiple apps, and you can tap off of it with multiple apps. So there's no problem at all moving audio around within Linux. All right, so we've gotten to the point where we're routing audio around inside the computer, one application to another. Let's talk a bit about setting audio levels, because if the audio level is too low, it makes for a low quality recording. If the audio level is too high, there's great potential for distortion and some really ugly kinds of digital mayhem. So set the audio levels to something that's reasonable. Podcasters will normalize their audio so that their peaks are about 1 dB below zero. You don't have to be quite so precise with it if you're more than a couple of dB below the top level in the digital domain. That's okay. The default audio levels from WebSDR and OpeWebRX are pretty reasonable. You can more precisely set it if you want. I would suggest checking it at least, because there's always the possibility that you could tune into a site that's misconfigured, or you might have some unusual signal levels, and it could drive the peak value or average value of the signal you're listening to near a limit. So check it. You should not have to make adjustments. Now, if possible, consider reducing the RF gain. This is one of the main problems affecting audio quality of recordings. I'll tell you a short story. My career background is flying in the airlines, and before that, as a teenager and in my college years, I did a lot of shortwave listening and made a lot of my own recordings, and I learned through trial and error how to not mess up the recordings and create something that other people might want to listen to as well. And that involved opening up the filters a bit, if possible, setting reasonable audio levels, filtering the DC power, and keeping out the hum and noise. And when I got into the airlines, to two different companies, actually 3 different companies, that did long-distance flying where we had to use the HF radios, everybody was trained to turn the RF levels all the way up. And I tell you, those expensive receivers and transmitters on the jetliners sound absolutely terrible. They sound absolutely terrible because we were all trained to turn the RF levels all the way up on those, and to get close up onto the microphone and just about yell into the mic. No good. I'll tell you what, when I upgraded the captain, the first thing I did on my oceanic trips was teach my co-pilots how to reduce the gain to a more reasonable level. Not so low that you miss cell calls, that you miss calls from ATC, but reduce the level for a little bit to reduce the listener fatigue. And it's funny. The one company I started with went out of business. I went to another company, and they were a bit more reasonable about the levels. They didn't drill into us that we had to turn it up all the way, but a lot of us came from other companies and had been through the mill already, and there was already a habit of turning the levels way up. So I did a bit of that same instructing in my second airline that was flying overseas. Turn the levels down to something reasonable, and you'll have less fatigue, and it'll sound better. And then the third company I went to that did just a bit of long-distance flying, they weren't much on understanding the principles and fundamentals behind what we do, and their motto was turn it all the way up, and you'd get yelled at if you didn't turn it all the way up. So I had a few clashes with people that insisted in doing stupid stuff with the radios. So I'll tell all of you, you don't have to have the gain turned all the way up. When you listen to these SDR sites, if you can, if you are listening to strong signals, strong RF signals, turn the RF gain down. Now what's really happening is that you're not really turning down the RF gain on an SDR. The input to the analog to digital converter is generally fixed, and it's high enough to get signals above the noise, and it's not so high that it's going to overload the ADC. What you're really doing with RF gain on an SDR is you're adjusting variables in the code that adjust the gain setting in the virtual realm. So what happens is the SDR tries to maintain a constant average level of audio output. If you tune in a strong signal, it reduces the gain. When that strong signal goes away, it increases the gain. And if there's a lot of noise on the frequency, guess what? That noise is amplified back up to that target average volume level. And it's absolute hell if you're not a radio person and you're trying to listen to that stuff. In fact, if you're making a recording for an archive or to share with other people or for a documentary or news report, that constant pumping of the background noise when there's a strong signal is unpleasant, and it can be avoided if you turn the AGC sensitivity down so that the background noise level stays low. If you're listening to a strong signal, well, that strong signal is going to be easy to understand, easy to hear. And when that strong signal unkeys the transmitter, what you should hear on the receiving end is a background noise level that stays relatively low. It's much more pleasant to listen to. Okay, I think I've gone on and on about that enough. Let's talk just briefly about weak signals and the RF gain before I move on. If you're listening to weak signals, you don't really have much choice. You have to deal with the background noise. My suggestion would be to set the gain to just a moderate level. You'll hear the background noise, you'll hear the other station, and you'll just have to bear with the racket. But don't turn it all the way up so that the needles are just pinned to the right and everyone's being blasted by racket. You don't need it to be so high, you just need a moderate level. Another item is recorder settings. Consider using as high a sampling rate for the audio as possible. Use a high sample rate, 48 kilohertz at least. If you can use 96 or 192 kilohertz, that's even better. Also, as far as bit depth, remember things like the RTL SDR are 8-bit devices, which is not really that good, but it's good enough. Some of the better SDRs out there are using 12 bits or 16 bits, which is good for radio work. For the audio work, again, use at least 16 for the audio. If you can use 24 bits, and again, use a high sampling rate, that's great. Set everything up as best you can and record at those rates. When you take that audio into the future and you process it, you edit it, you do all kinds of magic work to make the noise disappear, all of that is much better with more bits and more samples per second. And one more general tip for making recordings. Before you start tuning around, if you think there's something interesting that might happen on the radio, set your recording up beforehand, check the levels. If you can use a wider bandwidth for single sideband, widen it out some. The range 300 hertz to 3 kilohertz is pretty standard. If you can bring the low end down to 100 hertz and the top end up to maybe 3,500 hertz or 4,000 hertz, that's a bit easier on the ears. If you're listening to some of the high fidelity single sideband people in the amateur bands, hell, you can go all the way down to 20 hertz. And there's audio to hear down there. And you can go all the way up to 5 kilohertz, 6 kilohertz. Some of these SDRs will not go higher than that. If you are recording AM or FM signals, some of the better ones will. Use wider filters if possible. The narrow filters can cause distortion on FM, and when you're listening to AM, if it's a broadcast station, their sidebands can go out as far as 15 kilohertz either side of the carrier. That's pretty wide. It's not good if it's a weak signal because there's so much noise with the wide filter. But if you have a strong station, go ahead and widen those filters out. If you have interference on an SDR, you can change your filter pass bands to eliminate interference on one side or the other. And if it's generally a weak station, well, then you don't have much choice. You'll have to narrow the filter pass band to get rid of noise. I would suggest against doing a lot of processing on the raw signal. Just try to record a clean signal and later do the noise limiting, do the special filtering, do all kinds of magic in the digital domain later. But initially, just try to get a clean signal first. Okay, now let's go and listen to some SDR sites. What we're going to listen to first is a pair of WebSDR sites just to show you the controls and just to give an example of a pretty good quality audio recording. The screen capture is the screen capture. I don't have anything special to add for that. If you're using high-end video equipment with a high frame rate and 50 million billion colors, that's great. I think the interfaces only run a limited number of colors anyway, so let's think more about the audio quality. And there's nothing much I can do for the waterfall. The waterfall spectral displays are what they are. They're okay for finding signals, but there's no special magic in that. First off, let's check levels. What you see here is pulse audio volume control, and you'll see that I'm doing a screen capture using Simple Screen Recorder in Ubuntu Linux, and I have it set to monitor a built-in analog stereo. I do have some choices. There are some other things to check. I've got a virtual cable in here. I probably shouldn't call it virtual audio cable because that's a commercial product. Let's just call it an internal routing inside the computer. So I can move audio around from one place to another. It's not really necessary with this screen capture utility. Just monitor a built-in analog stereo is good enough. So let's get rid of that and let's move to the internet and tune in some signals. Okay, first we're going to Bedford, England, to Barney's WebSDR. What you hear is Shen involvement. Take a look up here on the address bar in the browser. I have the signal tuned to 5504.8 because that matches the signal. That's how I tuned in the signal with minimal error. He's using an RTL SDR, I believe, and it's all frequency by about 160 hertz, so I have to compensate for the offset by moving this thing down about 160 hertz. Let's scroll down past his bulletins and we'll take a look at the waterfall display. I have somewhat choppy internet right now, so the waterfall starts, stops, and the audio is doing the same, unfortunately. Let's zoom in. Let's go max in and center up on the signal. So you can see the symbolic representation of the passband and the phantom carrier for this single sideband signal. And also you see a pointer for where channel involvement should be. But again, there is a slight offset in his hardware over at Barney's SDR, so I have to compensate by tuning this thing down just a little bit. Well, it's going to be one of those days. My internet's not working well, and we're not getting any audio. This is crap. Let's do this again. The first SDR that we're going to visit is Barney's SDR over in the UK. Just to show you the top of the page we were visiting. This website SDR is located in Bedford, UK, and is operated by Barney. And there's his email if you would like to write to him, barney.qrp@gmail.com. Send him an email. Tell him to fix the offset on his SDR hardware. What I've done here is set the URL for this site to 160 hertz, lower than the actual frequency that I want to receive. Channel involvement is on 5505, and we're tuned to 5504.84. Again, that's to compensate for the offset in the station hardware. Internet is a bit choppy here, so you'll notice that the waterfall display moves, stops, and the audio is doing the same thing. This doesn't make for a very good recording. Let's add another item to the list. If you're going to record from an internet SDR, try to have good broadband. Okay, so there it is. That's what you're hearing. Take a look at the controls. There is a volume control here. We can move the level up and down. And for a good recording, we would set that to a moderate level. Let's take a look here. Pulse audio volume control. Let's see what it indicates. Those peaks are getting up pretty high. Yeah. So I'm going to move that level down just a bit so that we don't overdrive the recorder. And let's check for controls for the RF level. With an SDR, I shouldn't say RF level. Let's check for controls of the automatic gain control. Is that better? Okay, we don't have that control here on this one. Let's check a more recently updated WebSDR. We'll go right to the source at the University of Twente in the Netherlands. Whenever there's an advance in the WebSDRs, this one will get the advance first. It's an absolutely fantastic site. They have fantastic servers and a really good computer system, and they can handle hundreds of listeners. So, here we are at 5505, channel involvement, and the signal is absolutely fantastic. Let's see, let's go max in. That's as close as we can zoom in on that one. We'll leave the volume at the default volume level. It's high enough, but not too high. Now, There's an advanced tab at this site, and on this advanced tab we have access to the automatic gain control for this receiver. Gain control automatic, and there's an adjustment for the hang time. You can maximize the hang time so that the background stays quiet after a strong signal, after syllables in a person's voice, and for a certain amount of time after they stop speaking or after an AM signal drops carrier. It's very pleasant listening with a long hang time. Now, to minimize the hang time will cause the gain to increase in between the syllables of this person's words. Actually, Shannon Volman is not a person anymore. That's a computerized voice. But notice the pumping action of the background noise. We can't directly keep the AVC and set a particular gain setting as the default, but another thing we can do is turn off the automatic gain and go manual. When we go manual, we have to manually adjust this down to a lower gain setting. It is possible to adjust the gain to so low a setting that you cannot hear anything. Since I know that Shannon Volman runs continuously and over relatively short periods of time, the signal strength will be about the same. No other stations are going to come on. It's just Shannon Volman, so I can set it there and leave it. Again, the internet is just a bit choppy, so the SDR signal drops out from time to time. Let's lower that gain just a bit. Now, if you're going to make a high-quality recording and archive it, set something like this. In the future, when you're preparing it for a presentation, well, you can adjust the gain anywhere you want. You can run some kind of advanced noise reduction on the audio. You can do all kinds of things. I mean, you already have a good quality recording to start with. Alright, so there's the SDR at the University of Twente. Let's go and work with settings on a couple of different OpenWebRX sites. The first one we'll visit is the DF0KL, Delta Fox 0 Kilo Lima site. It's an excellent configuration over there. Not much noise, good settings, and it receives really well. We're using about a 4 kilohertz bandpass on upper sideband. The frequency is 5505 Shannon Volmans. First, let's adjust the waterfall settings. My personal preference is to set the waterfall max to about -40 and raise the waterfall minimum to darken the background noise. Minus 134, 131. Something around there seems to work for the current conditions that we have.
Dublin, valid from the 27th at 18:00.
The fast waterfall rate is okay.
The 28th at 1/8.
It uses a bit more bandwidth, but streaming is good right now.
0 degrees, 12 knots. Visibility
Going into the audio settings,
cloud, few
turn off the
at
compression for better sound quality.
broken at 1,500 feet. Probability 30%.
AGC settings. Let's start by turning off the automatic gain control and working with manual gain. The default is 50 dB. We'll slowly increase the gain and find where the distortion begins to have an effect.
Between 2300 and 0100. Wind.
Alright, there it is, in the mid-70s.
Probability 40%. Tempo from 0500 until 0900.
61 dB of gain seems to produce a clean signal
900 feet.
and a moderate level.
Becoming between 0700 and 0900.
We'll turn AGC and the hang feature on.
0 degrees, 15 knots.
Notice that reducing the decay time results in quite a bit of background noise pumping in between the syllables.
The 27th at 1/8.
Increasing the decay time will cause the gain to stay reduced in between syllables. And if we go all the way up to 5,000 milliseconds, the gain will stay reduced between short pauses in speech.
At 2,000 feet. Becoming between 1900
That sounds much better than the default.
and 2100. Wind 010 degrees, 7 knots. Becoming between 0000 and 0200. Wind 040 degrees, 1
You might notice a lot of parallel lines on the waterfall display. I've seen that on several different SDRs in Europe. There is some kind of a noise source out there,
Gusting 25
and that
knots.
signal, that broad bit of spectrum is noticeable all over the place. I don't know who it is and why it's there.
Broken at 1,400 feet.
At any rate, let's change the decay time back to 20 milliseconds, and let's do something to make the sound a bit more natural. We'll change the slope characteristic of the AGC, and then lower the threshold as we go into the 60s. There's minus 60, minus 57. Back to minus 65. The background noise is reduced, and the signal sounds pretty good.
10 kilometers or more. Cloud, few at 2,000 feet. Ceiling broken at
this point, changing the
600 feet.
decay time does not have much effect. The gain is already reduced by the threshold setting.
Manchester, Metroport, Manchester.
The only real effect for changing the decay time now is that if there's a very strong signal that comes up on frequency, or if the signal fades strong, then it'll protect your recording, cause you not to have much distortion. Bringing the threshold all the way back up to minus 130. You'll notice that the decay time will keep the gain reduced in between syllables. If the signal fades, though, you will be subject to quite a bit of noise.
4,300 feet. Temperature 0.
Now, for a few moments, let's reduce that decay time again to make a point about the rapidity of the automatic gain control and the effect on background noise. This gain is reducing during voice peaks, and in between the voice peaks, the gain is increasing, and it's really bringing in that noise quite loudly. What you really need to do to prevent swamping your recording with background noise is to reduce the threshold. You can see here a setting someplace around, let's say, minus 72, keeps the gain reduced. And then protection against strong fades You can then set a decay time either near the default 1000 or set it to a longer time to protect in between brief pauses. And these will be more noticeable if the signal takes a very strong fade up in strength, or if it drops down in strength because of threshold setting. You'll be protected from excessive bursts of noise.
At 1,500 feet.
And you can make fine adjustments, a few dB this way, a few dB that way, until the level of background noise is suitable for your recording.
Visibility 5 kilometers. Light rain, light drizzle, mist.
The propagation on Shannon Volman is interesting. The selective fading is a periodic thing. It comes and goes. Sometimes we can see the whole pass band is coming through with no problem, and then just shortly after that, the dark bands start to angle across, and we can see the selective fading is returned. Also, the noise source seems to cut out and then cut back in. You can see that in the vertical lines in the background. Okay, let's talk about audio for a moment. After making the adjustments to the RF gain,
3,000 feet.
or virtual RF gain in the SDR, it's then a fine time to make the last adjustments to the output audio level. You can see here we've brought the audio up slightly.
At 1,500 feet.
That makes for a nice moderate audio level into the recorder.
1000 and 1200. Wind 270.
Well, there's nothing much else to add in this not so brief lesson on adjusting SDR settings for best audio quality in a recording. I hope this is helpful. Happy hunting. Good luck. I hope you find fantastic signals, interesting things to archive and share with others. Bye-bye.
Cloud, few at 2,800 feet.